So we're going to continue. We're going to continue from where we ended. Yeah, if I remember correctly, we were doing some exercises. Yeah, so there was one exercise which we didn't do. So we'll start from there. Then after that, we can start a new chapter. So I didn't send you the homework because there was they still remained one exercise which we were supposed to do together. Yeah, so I will send the homework today. Yeah, after the lesson for this day. I'll send, after we're done with everything, I'll send the homework. It will be just 2 questions, which I want you guys to research, and and you should send me the answers before Monday. Yeah, so without wasting time, we're going to start with our today's lesson. Are you able to see my sharing?
Yes.
Hello. Are you able to see my sharing?
Yes. Yes.
Oh, okay. So we're going to answer question 3. So basically, a quick rappel, a quick rappel of the things which we did last time. So we did the charges. We looked at the charges, and the 2 exercises which we did. We are looking at charges punctual, which means the charges which are fixed, which you can be identified, which can be easily identified. But exercise 3 is dealing with it. Density linear the charge. Mean density. Density, it means a cloud of charges where the charges can be found. I can say anywhere. Like they don't have a fixed point. Or they don't have a fixed point. It's like a cloud of charges where if I move from one point to the next point, I will still like the charges will still be the same. But for the punctual, we say that it's a fixed charge which you only find it at one point. When you move at another point, you won't find it. So how do you calculate the how do you calculate the force when you are when you're given density, the charge, when you're given a cloud of charges where these charges which you can find, these charges which you can find almost anywhere, and when you move, you can at any point you still find the same charge. So how do you calculate this force? So that's I can say that's the exercise for today. That's the exercise. That's what we're going to deal with this exercise 3, which is density linear the charge. So basically, when you see density linear, you should know that they're just talking about the distribution of charges, a cloud of charges, where you can find them almost everywhere. And you can find them almost everywhere. And in this case, we use the same formula as force, the same formula for force, but where there's Q, the charge Q, you replace it by you replace it by dq, differentiation Q, which means the charge is always what? In a changing state. It's not at a fixed state. The charge is always in the changing state. If I try to move from one point to another, I will still see I'll still find the same charge. So you're going to understand more when we start doing the exercise. So exercise 3 is density linear the charge, and is what it starts. Un fil de section negligible en forme de cercle. So they're saying a fil is I can say a string, somehow like a string. So they're saying un fil de section negligible, meaning this string has no what? Has no surface, is of a section negligible, meaning its surface area is really small in such a way that we neglect it. We don't consider it. So, un fee de section negligible en forme du circle. So they're saying this fee or this form of a string, which is in form of a circle, the center on, which has the center on, and the rayon R, which means the end of radius R, placed dans le plan X or Y. So it is placed in a plan X or Y. So they're saying that there's a string which has in which each section is negligible, or in which each surface is what negligible, and this string forms a circle which has a center O and a radius R, and it is placed in the what? In the plane X or Y. And porter un charge électrique réparti avec une densité linéaire lambda. So when you talk about density linear, so it's really important to understand when they're talking about density linear, what do they mean? When they're talking about this density surfacic, what do they mean? When they're talking about density volumic, what do they mean? So yeah, so just a quick rappel, just a quick reminder. There's something. Yeah, I think it's here. Yeah, so there, like in each question, they'll be specifying, there will be density surfacic. I think you can see my sharing, the charge, the density linear, the charge, and the density, density what? Density volumic, the charge, which is the first one. Density volumic, the charge. So basically, there are three ways I can say in which these charges might be distributed. Like this cloud of charges must be can be distributed. So these charges can be distributed in, I can say, just a small part, just a small volume of a larger part, which is density volumic the charge. So when you hear density volumic the charge is the quantity of charge which is found, I can say, in a certain volume, in a certain volume, and this formula is rho, this is rho, is equivalent to dq. Dq, it means the charge. Q is the what, Q is the sign for the charge. So dq is the charge, and I said that we add d because it is showing this charge is, it can found anywhere, meaning it's in a form where if I try to, like in this, for example, imagine a volume like for example a cube. Yeah, a small volume, which is like I can give an example of this one, a small cube. You imagine this small cube. If I try to move at any point in this small cube, I'll still find the same charge. That's why you see dq. Dq meaning you can move at any point of this cube, you still find what? The same charge. So that's why I see dq dv. And for surfacic is only the charge which is defined on a surface of something, like I can say a small surface. So this one is denoted by, so the most important thing is knowing the formula. This one is denoted by this is sigma, yeah, sigma, not omega. This is sigma. I remember the omega and sigma, they are a bit similar. So, but you should know that this is sigma. I remember there's one of the videos that said omega, because these two I usually confuse them. So this is sigma. Sigma is equal to dq divided by what? ds. Sigma. So this the sigma, the lambda, the what? They shouldn't confuse you. They are just there to just make the difference between density surfacic, density volumic, and density linear. Density what? This density yeah, this density lineate. Yeah, so they are there just to make it a difference. So for density surfacic, when you hear density surfacic, you should know that it is sigma is equal to dq, which is the changing of the charge divided by ds, which is the surface which you have been told to define. Then for volume is dq dv. So the only difference is the denominator, the denominator. The numerator is always dq. dq for volumic is dq, for surfacic is dq also, but the denominator, the denominator is ds. Then for density lineate is formula is lambda is equal to dq divided by what? dl. So these are the formulas which you have to know. So I wanted just to remind you about these formulas before we tackle our question, because you have to have these formulas in your what? In your you have to have them in your head. You have to be able to remember these formulas. So there's lambda dq dl, which is for linearic. Surfacic lambda dq ds, which is surfacic is sigma d is equal to dq dl. Then volumic is rho is equal to dq dv. So dq dv for volumic, rho is equal to dq dv. Then for surfacic, sigma is equal to dq ds. So now, knowing that, we're going to now answer our question. So yeah, so as we already started, the question is, you have been given a string which is unfit, the section negligible, which has a section negligible, and note that we are in density lineate, which means you are using the formula which is lambda, like under dq, you replace it by the formula which is lambda is equal to dq over dl. So unfit the section négligeable en forme d'un cercle de centre 1 et de rayon R placé dans le plan X ou Y, porter une charge électrique répartie avec une densité linéaire lambda. So density lineaire lambda, we say that is so denoted by lambda. So here it says lambda is equal to, they have given us what our lambda is equal to. Lambda is equal to lambda 0. This is just a capital 0, which is trying to just differentiate it from the actual lambda. So lambda is equal to lambda a small 0 sine theta. So this is, yeah, so lambda sine theta, où lambda est une positive and theta is equal to OX OP. So you are going to see this when you go to the diagram. P est un point quelconque du cercle. So they're saying this, the charge P is a point quelconque du cercle. So meaning, when they say so, meaning this P, I can present it wherever I want. This P, I can, since we are dealing with it, density, a cloud of charges, it means that there are charges all over this circle. When you hear density linear, you should know that they are talking about a cloud of charges. So there are charges around this circle. So if I want, I can represent a charge here. If I want, for me, I've represented it here. But if you want, you can present it here. If the other one wants, can present it here. If the other one wants, can present it. You can present it anywhere you want around this circle. So yeah, so this is a string which is in a form of a circle. They've said you have a string which is in a form of circle, and this string has a center O, and the radius r, which is this radius, and we have also said that this circle, or this this circle has an angle which is theta here, which is OX OP. So it has an angle which is what? OX OP, which is this angle here. So basically, most of the time you'll be given in a form of, I can say most of the time they give you in a form of a question. Then you have to imagine this circle. Now you have to come up with the drawing, but sometimes they can give you with the drawing, but there are times where they just give you information and you have to imagine the circle. You have to imagine the drawing. So here, if you are imagining the drawing, you should know that when you talk about unfit, we are talking about the string, and they'll say that it's in a form of a circle, which is the thing which I've already explained here, and it has a center O, which is there, and the radius R, and it has an angle, which is OX, and which is between OX, which is OX and the OP. So OP, the point OP, I can present it anywhere. And they have said that your lambda is equal to lambda sine theta, where lambda is in positive. So they have said that you have your lambda is equal to lambda sine theta, where your lambda is greater than 0, meaning your lambda is positive, is always positive, but your sine theta, they haven't what specified. Your sine theta, they haven't what specified. So you know that your angle, if you move from, if you change your angle, this one you have to know this one. You should know that when you change your angle from, if you're using sine, if you change your angle from, if the angle changes from 0 to pi, which is 0 to what? 0 to pi. Pi basically is 180. So when you change your angle from 0 to 180, your sine theta your sine theta to be always greater or equal to what? 0, meaning it will always be what? Positive. So where there's this angle here, you place from numbers which are starting from 0 to 180, you'll find that you'll be having most of your I can say most of your answers. If you try this, you'll find that you'll be finding positive or an answer which is equal to what? 0. Then, which means that this formula here, since here, if you place 0 and if you place numbers which are equal to 0, if you place angles which are equal or less than 0 and if you place angles which are equal or greater than 0, or angles which are between, if you place like angles which are between I can say which are between 0 and pi, you see that you'll be having your answer, which is your lambda here will always be positive. This thing you should do also note. So here, if I place 0, if I place 10, 20, 70, 80, it will always be giving me a positive answer, because this lambda 0 is always, they have said is always positive. So the one which determines here, see, this is the sign here. Then you should also know that if it is between pi and 2 pi, your sine theta is always less than 0, meaning when you place here on theta, when you place numbers which are between pi and 2 pi, you always get a negative. You should try that. You always get a negative. And if you always get a negative, which means that your sine theta here to be negative, and negative times positive, your lambda here to be less than 0, which means your lambda will be also what? Negative. So these are the things like you have to know. These are just things which you just have to know. So basically, when you are given a question, you have to check what have you given, what have you been given. So they gave us the formula of, they gave us what lambda is equal to, and here I was just trying to explain in cases where your lambda can be negative or positive. So you have to know that information is really important. Then, yeah, you have to know that information is really important. Then now, how do you find the force? So here the question was, find what? The force which is created on point what? O. The question was, find the force which is created on point O. So how do you find the force which is created on point O? By this charge P. Since we say that basically we say that when you have two charged particles, you have, for example, in this case, you have got P is a charged particle, and this P is causing a force on this point O. So you see here that the force is coming from P going to what? To the point O. So how do you find its force? So we know that the formula for force, F, we know that the formula for force. So in this case, you write dF because the charge here is a distribution. So basically, when you're given density to the neck, density surface, your force is, you have to do some integration. You have to be good in it. So electricity basically is dealing with in the integration, the what, all those things. So we use this formula, which is dF is equal to Q0 dq divided by 4 pi epsilon 0 r squared up 0. So you see dq where the force is being dF is equal to q0 I can say q0 is this point here, qo times dq is the charge, this charge here, which is creating a force on hello. Yes. Don't know if you have a question.
So to take it. Yeah, so to take it back. Yes. What do you mean when you say that the pi is equal to 180?
The pi is equal to what? I don't get
when you said pi is equal to 180. What did you? I'm saying, what did you mean when you said that the pi is equal to 180?
Oh, okay. I can say basically here, what you should know, angles, when they are representing angles, they present them in terms of pi, 2 pi, pi over 6, pi over 4. That's the way they present them here. It's rarely when they can write the actual number, which is maybe 180, 360. So what you should know just is that 2 pi is equal to what? 360 degrees. Yeah, 2 pi is equal to what? 360 degrees. So this is, I can say, this is a general formula which can help you to know what is your 30 degrees, what is your 180 degrees, what is your 60 degrees, what is your 70 degrees. This will help you. So basically, since here, yeah, if you remember your secondary mathematics, where you do those, the equating, the what. So if what you should know, the general thing which you should know is that 2 pi is always equal to 360. This is something which you should always know. Yeah. If you know this, you solve anything. So if 2 pi is equal to 360, what of x, which is equal to 180? You'll find that x 180 is equal to what? Pi. So if you do the cross multiplication, if you do those things which you do the cross multiplication, you find that the pi is equal to 180, or if you don't want, pi always is equal to 180. So if you should know that pi is equal to 180, 2 pi is equal to 360, then these others you can calculate without any problem. So that's how the angles are presented here. The angles are presented in terms of pi. You'll find, yeah, for example, 30 degrees is pi over 6. When you see pi over 6, you should know that it is 30 degrees. The angle is what? 30 degrees. So if you see pi over 6, you should know that the angle is 30 degrees. But if you don't know what pi over 6 is, you can just do your simple mathematics. So what you should, like, what I can advise you just is, you should know by heart what pi is equal to and what 2 pi is equal to. It's something which is, you don't need calculation. It's something which is there. I can say that's how it is. 2 pi is equal to 360, then pi is equal to 180. I don't know if it's clear. Do you want to ask a question?
Oh, yes, thank you. Yes, clear.
Okay, yeah. So you should just know that pi is always equal to 180. Then 2 pi is equal to 360. So that's how the angles are represented here. Like, yeah, that's how the angles are presented here. So so we are on finding the force which is created here on O. So this P, you know that this P is creating a force on what? On O. And this O here, we'll say it will be this O is Q0. Since when the charge here creates a force here, it causes the particle which is here in the middle to move either outside or either to be attracted, depending with the charge of the particle which is in the middle here. So imagine there's a particle here. So imagine those two my diagrams which we did when you said when it's positive, you see the repulsion. When it's positive, negative, you see the attraction. So this is the same thing here. So we see here that there's a charge here which is causing a force here. So here we'll call it Q0, charge Q0, and here we'll call it charge Q. So the formula for force, you know that the formula for force is equal to Q, which is for where you cause the force, where the force is exerted, times another Q, another Q, a charge, I can say a charge which causes the force. There's a charge which receives and a charge which causes the force. So when you're calculating the force, you have to get, I can say you have to include both charges. You have to take notice of both charges, which is the charge which receives the force and the charge which gives the force. So the charge which gives the force, the charge which is found on P, which we name what? Q, and the charge which receives the force is the charge which is found on O, which we will name it what? Q0. So here, if you see here, the charge which is found on O is a charge which is a fixed charge. I can say the charge which is found on O is a fixed charge in such a way that when I say fixed charge, I mean that this charge, it will be, it's not found, there's no distribution, like there's no distribution of this charge. This charge is always found on the same point, because whether I change this point, it comes here, it will still create the same force on this charge. If I change it, it will still create the same force. If I change it, it will still create the same force. So there's this charge on is the one which is changing. The charge on is the one which is changing. And why I'm saying is the one which is changing, because they have said that P était un point quelconque du cercle. So here they're just saying that P can be any point on the circle, any point which you wish to choose, like on the circle, that can be P. but the center O, it always be the center O. You can never move from another point. So the force which is created here, this one is a constant. It always be here. It will never change. But the charge which is here is in a constant change. That's why you have seen here, I've put what? dq. So it will be q0 times dq divided by 4 pi epsilon, which is times your radius. This is your radius, r, which is r squared times r squared. If you remember the formula, it was q times, it was q times q divided by 4 pi epsilon 0 distance. The distance is our initial formula. The distance is the distance between the two charges, and here the distance between the distance squared. So the distance between the two charges is what? Is r. That's why I will place here r squared d with a vector u p o. So we have a vector, since it's moving from p to o. Here the charge is the same as 1. It's the same, if you remember where I said it depends where the force is coming from, who is giving the force. So you have to know which one is giving the force. So here the charge on p is the one which is giving the force. So it's moving from what? P going to o. It's just the same thing with the one which with numbers, where we had charge 1 and charge 2, where we saw that when it is moving from charge 1 to charge 2, you would say vector u 1, 2, meaning it's moving from 1 to. So in this case, it's moving from what? PO. So you have to place the vector u PO. So I don't know if you are clear on the formula before we move on. Are you clear on the formula? If you have any question on the formula, so basically you just have to know the formula, which the formula for force. Then if you know the formula for force, if you are fast, yes, you can ask. Hello. Someone wants to ask a question? Is there anyone with any question? I can hear someone wants to ask. Yeah, if there's no one, we're going to continue. So you just have to know I think there's someone who has a mic on. Yeah. So you just have to have the formula for force. So the formula for force, you know that so it's nothing really complicated. I can say so. It's nothing really complicated. This is the formula for force. Yeah. So this formula basically, if you see this formula basically, this formula is used here. I've not put dq, dy because they are charges punctual. So for charges punctual, charges which are distributed, you use the same formula, but the only difference is that you see that one of the point, it will be in a constant change. Like one of the charges, it will be, you can place it anywhere. It's a distribution. That's where word distribution comes in. So it's a distribution. So one of it, the one which is actually most of the time what you should know is that the one which is causing the force, the one which is causing the force is the one which is most of the time is the one which is always in a constant change. It's the one which you write dq, which is always differentiation, like it's always changing. Yeah. So here it's just the same. So you just have to know this formula. If you know this formula, you are well and good. You won't have any problem. So you just have to know this formula. So in terms of charges which are punctual, which are fixed. Like for this case, you just use the formula direct, and yeah, just use it. Yeah, you don't put the DQ, the what, the differentiation, those things. You don't put them. You just use it directly. Yeah. So in this case, since we have in our question, we have a distribution linear. So it means there is a change, and the one which changes basically most of the time is the one which is causing the force. So this is actually there's the formula. There's no difference in the formula, just that we have dF. dF is the force differentiation of the force, which is the force will be, since this point P can be presented at any point, meaning the force, it can, there will be some changing of the force. That's why you are presenting it as dF is equal to Q0 dQ divided by 4 pi epsilon 0 R2 U P O, the vector U P O. P where the force is coming from. So now after you have written your formula, so when you have written your formula, then it means now you can start doing, you can start solving. So when you start solving now, you have to know what your DQ is. So first you deal with your DQ. What is your DQ? So for you to deal with your DQ, what does your DQ is? So you have to deal you have to deal with your DQ. Your DQ is equal to what? So you have to know what your DQ is equal to. So first of all, you have to see in which I can say you have to know in which kind of distribution am I working in? Which kind of distribution are you working in? So you have to know that one. That one is very important. So here we have said that it's density linear. So if it is density linear, we said that the formula for density linear, if you go to your book, is lambda is equal to dq divided by what? dl. So if you do your cross multiplication, you have dq is equal to lambda dl. So the dq is equal to what? Lambda dl. So where there's dq here, you can replace it by what? Lambda dl. But but before you replace it, you have to know what is your dl. So here now, that's where it comes in. The things which we did, the coordinates, the what, that's where the coordinates are important here. So you have to have, so when you're solving this question, you have to be familiar with it, the coordinate polaire, coordinate Cartesian, coordinate, all those coordinates you have to be familiar with. So here, what will be your dl? So here you should know that this is, if you see this circle is in a form of what? Coordinate polaire, because we have said that this section is negligible, meaning this area is what? Negligible. So we are dealing with what? I can say we are dealing with a coordinate polaire, and this coordinate polaire, we say that the coordinate polaire is defined by what? Radius and theta. That's what we said. And if you see here, there's something which is constant here. You see that the radius is what? Is constant. So if you do the differentiation of the radius, it will give you 0. The dr or d rho, it will give you what? 0. So the only thing which you, since r is a constant, the only thing which you remain with is what? R d theta. I don't know if you are clear here. So this lambda r d theta is the one which is going to replace what? dq. That's what I've seen here. I've replaced it with what? Lambda r d theta. So this is where it's coming from. So you just have to know how to use the coordinate polaire, the coordinate series, the coordinate, all those coordinates, they come in hand here. If you don't know how to use, yes?
Just repeat once more. We got the R d theta.
Okay. I was saying that since you want your dl is if you remember there, when you said the L, we were saying the differentiation, the movement of a point, the movement of a point from M to M prime. If you remember the M to M prime thing. So here they want you to find your DL. Imagine, so since you are dealing with this circle and you are dealing with a circle, and if you are dealing with a circle, if you are dealing with a circle and they have told you they have told you that the distribution is descending to linear, you should know that you are using what? You are using coordonate polaire. And we said that coordonate polaire is defined by two things, which is rho. Rho is just the radius, which is represented by r here, and the theta, which is the angle. So here, if you see here, the formula for the formula for dm m prime is equal to d rho e rho plus rho d theta. So we have said that the rho is what is the radius. If you remember those, if you still remember the coordinate polaire. So the m prime is equal to d rho e rho, which is vector e rho, plus rho d theta, vector e theta. And if you see here, you have the radius, which is the radius r, which is just equal to the radius, which is rho, which is just equal to r. And if you try to move this point around this circle, this radius will always be the same, which means that the radius is what? Constant. So if the radius is constant, if you remember those questions which I was giving you, if the radius is constant, it means that the differentiation, the d rho is equal to what? 0. So that one, you remove the d rho, so you only remain with the rho d theta, which is just the same as the r d theta. That's where the what? The r d theta comes in. When the r d theta, that's where it now comes in. That's why you have seen that I've just written what? R d theta, because the d rho, which is just the same as the dr, is equal to 0. The radius is equal, the differentiation of the when you differentiate a constant, you always get a 0, you know. So this is r is a constant. So that's where I can say that's where we have excluded the rho e rho. We have just written rho d theta, which is just the same as r d theta. I don't know if you have understood.
Yes, thank you.
So basically, this, you know, if you know the coordinate polaire, the coordinate cylindric, you won't have any difficulties here. So now we have replaced our dq. So our dq is equal to lambda r d theta. That's, you have done the replacing. So after you have done the replacing, now there is another step which you have to do. This other step is, so this thing when you're solving it, you have to follow. There are some steps which you have to follow. So now there is another step which you have to do. So for you to since you are calculating the force here, and you know that when you create the force which is I can say the force which is caused by this charge here at to this point here, the force which is exerted by this charge to point O, it can cause, I can say it can cause either repulsion or attraction. So you see here that since you are moving from what? You are moving from P to O. You're moving from what? P to O, meaning the charge is, the vector is from what? The vector is from from this charge which is on P going to O. That's why you have seen I've written UPO, which is UPO. But I have to change it in terms of what? In terms of since the force is created here, so I have to change it in terms of the opposite of it, in terms of I have to change it in terms of its opposite direction. I can say the vector, since you always know that the coordinate polar, for the coordinate polar, a vector always moves from, you move from the center O going towards outside. This is the UR. If you remember your under coordinate polar, you know that the vector which presents the radius is always going from the center going outward, which is usually you can present it as U rho, but in this case, since they have said that the radius between O and P is R, so I will just represent it in what? In UR, since they have given us a letter to represent this radius. So I'm just going to note it as what? UR, and this UR is moving from the center going outward, which means that the UR is I can say the vector UPO is equal to the opposite, is equal to negative UR. Why is equal to negative UR? Because the vector UPO is opposite to the vector UR. So here I'm trying to introduce the knowledge of polar, which I know, the coordinate polar, which I know, for me to calculate the force. So here I'm going to define it in terms of what? The radius. I want to define it in terms of the radius. That's why I have seen I have to change it to what? To vector UR, and the vector UR is the vector which is coming from the center going outside, which is the opposite of the vector PO. That's why here I've seen I've written UPO is equal to negative UR. So this is the step which you have to know. So after I've done that, you see that I'll just replace UPO, which is here. I'll just replace it with negative UR, which is DF is equal to negative QO, negative Q0 times lambda times R times D theta times vector UR divided by 4 pi epsilon 0 R squared. I don't know if it's clear until here.
Sorry. My network was tripping. I didn't get that clear where you got that negative Q0.
Okay. That's so. What I was saying is, since we have known that we are working with coordinate polar, and if you remember the coordinate polar, you know that basically most of the times we were moving from, like, your vector. We had two vectors. Sorry, we had the vector E theta, which is for the angle, and the vector E rho, which is for the radius. So here in this case, since I'm given that the radius, they have given me the letter R as the radius. So here, what I shall do is I shall consider UR as my vector, which is just replacing the E rho. Just think of the E rho. So the UR is just equal, is just the same as the E rho, the vector E rho, which we have already looked at. So here now, where is the negative coming from? So you know that the charge on P here is the one which is causing the force on charge on charge Q0, which is on O here. So you know that the vector is moving from, this vector is moving from P to O. That's why I've seen that it's vector PO. This is the vector which I have represented here, the vector what? PO. Then now, how do I want, my main goal is I want to change it in what? Coordinate polar. I want to change it in form of what? The coordinate polar. So now my question is, how do I do it? So since this one is towards the center, and I know that coordinate polar, the vector is always going outward the center. So it's going, yeah, if you see here, it's going what? Outside the center. So if you see this arrow here is the opposite of this arrow. So the opposite, you know, most of the time, the opposite of a positive we see just negative. That's why I've seen here, UP0 is equal to what? Negative UR. That's why I've represented it in terms of negative UR. So negative UR, I'm just showing it that it's the opposite of what? UP0. That's why if I come here, I'll just replace where there's UP0, I will put negative UR. That's why you have seen that your DF is equal to negative Q0 lambda times R times D theta divided by 4 pi epsilon 0 R squared UR times UR. So I don't know if it's clear.
Yes, it's clear.
Yeah. So now, after you are done, so these things actually is you being familiar with these things, because you have to know what you are doing and you have to know what is my next step. So you have to know what is my next step, what should I do from here, from there, from what. So here it's just a matter of changing what, all those things. So you have to be familiar with these things. So now we have presented it in form of the polaire. UR is the coordinate polaire. So now my main goal now is, since if you have seen the I can say, if you have seen we are using the X or Y plan, the axis, we are using the what, X or Y what plan, and we said that you know that if you remember, the first thing which we did when we started the topic, we did Cartesian. And if you remember Cartesian, I told you that under Cartesian, we use coordinate X, Y. Under Cartesian, doesn't plan. Doesn't plan meaning it's only presented by X and Y. It's not doesn't space is in 3D, which is X, Y, Z. So doesn't plan. You remember that we said that it's always represented by what? X and Y. So now we have to find a relationship between UR and I can say the coordinate polaire and the coordinate what? Cartesian. So here, basically, we're going just to deal with the UR. So we have to change it. We have to change it in terms of what? The vector X and the vector what? Y. So the first thing we have changed it in terms of the coordinate polaire, which is the vector UR. Then from the vector UR, we have to change it in terms of the vector X and the vector what? The vector Y. So how do you do that? So if you remember, if you just if you go back to the coordinate Cartesian, and if you if I'm not mistaken, it's under coordinate polaire or under coordinate spheric, you'll find they gave you some I can say they gave you some relationship between coordinate Cartesian and the coordinate polaire or coordinate cylindric, since coordinate cylindric is one of the coordinate polaire. So if you check there, you see there is some they gave you some how can you connect coordinate polaire with coordinate Cartesian. So you should know that your UR, which is, since we have said that the UR represents the radius, which is OP, your UR is equal to X UX. If you remember, imagine there's not this circle, you have a coordinate Cartesian. If you remember, we said, if you remember, there was a vector which was EX, there was a vector which was EY, and there was a vector which was ERO on the middle, if you remember. So how do you do it? So here we have UR is this radius OP. So this radius OP. So how can you find this radius OP? So if you see here, you are creating something like what? A right angled triangle. So for me to reach at this point P, I have to move the distance, which is what? X under the vector UX in the direction of the vector UX meaning this side, plus the distance Y with the vector UY. So if you see the relationship between the UR is equal to X, UX, for me to reach at this point, I have to move X, which is the distance X. You have to move X, this distance X, and my direction should be towards what? Towards, I can say I have to move towards my right side, which is UX. Then after that, I have to move Y, my distance, which is upwards, towards the direction, which is what? The upward direction, which is the vector UY. So from there, you have just to know that you have to do some, basically, you have to know what your X is and what your Y is. So for you to know what your X is, you use the Pythagoras theorem. So you know that the Pythagoras theorem is this one. Under the Pythagoras theorem, you just have to know it in your head, like you know if it's what. So under the Pythagoras theorem, you make a right angle triangle. If you see here, it's making a sort of a right angled triangle. So for you to find your X is this distance. So your X, you know that your X is for you to find your X is, since the angle is touching the radius, which is R, and your X, which is the down line here. So you know that this one, it will be what? It will be the line for X to be adjacent, and the radius always is hypotenuse. So you know that you have to use K, which is cos theta is equal to X over UR. UR is this one here. The module of UR. This is the formula which you just have to, yeah, the module of UR. Then your X, yeah. Your X is it will be just equal to cos theta over your X, yeah, your X will be just equal to cos theta over what? UR. Then your, no, I made the mistake. This UR was supposed to be here. It was supposed to be X over X divided by mod UR, and mod UR is always 1. So here we were just supposed to, I was just supposed to divide it here, this side. Yeah, when I was writing, I just made the small mistake. So not this one. It was supposed to, since X is the adjacent, divided by the UR, which is what? The hypotenuse. So divided by UR, which is the hypotenuse. So this UR is in the form of a module. And you know that a module, when you square a module, actually is a square root of UR squared. And you know that UR squared is always equal to 1. The square root of a vector is always equal to 1. That's why you see that it will be X is just the same as X over 1, and which will give you is equal to X over 1 is just the same as X. So it will be X is equal to cos theta. So your X will represent cos theta. And here, also here, your UR must be here down, your Y divided by your UR. Then your UR is just equal to 1 since it's a module. So it will be what? Y is equal to what? Sin theta. So after knowing what your X is, and after knowing what your Y is, you just replace it now where there's X and where there's I. So your X is cos theta plus sin theta. So I don't know if there's anyone who haven't understood here. So this is your UR. So where there's UR, you just replace it by this formula. So for you to really understand these things, you have to go back to your coordinates. You have to go back to your coordinates, and you have to do a lot of questions. Like you search for questions, you do. That's when you understand, because this is these things is just a matter of practice. How much do you practice them? If you don't practice them, I assure you, even if you read the book 3, 4, 5 times, you can't answer them, because it needs someone who practice. And when you practice it, you will be able to think very fast. You'll be able to think very fast. You'll be able to know, I have to do this, after this, I have to do that, those things. So basically, the question, like most of the time, the question are just the same. They're similar, I can just say. You just have to, you work, I can say they are not really different the way you work with them. Yeah, they are, most of them, they are similar. So if you able to answer 4 or 5 questions very well, meaning you won't have any problem. So I don't know if there's anyone who has any question here. Yeah, so if there's no one, so now we have said that we have come up with the relationship between UR and the coordinate Cartesian. So this relationship is UR is equal to cos theta UX plus sin theta UY. So I'll just replace it to where there's what UR. So where there's UR, I'll place it with cos theta UX plus sin theta UY. So why are we using the vectors UX and UY? Because here I'm dealing with it. Here they've given me Y and X. So I'm dealing with my X and the, I can say my X and Y plan. Yeah, I'm doing with my X and the Y plan. So here I have to find a way of introducing my vector UX and the vector UY. It's really important. You have to know where are you working in. Is it the X or Y? Is it the, you have to know the plan in which you are working in. And if you know this plan, you have to try by all means to solve your solution in terms of the plan which you have been given. So that's what I was doing. So from here now, you have come up with this formula, which is cos theta UX plus sin theta UY. So now there's only one thing which you are remaining with. One thing which you are supposed to, I can say one thing which you are remaining with. And this thing is, you are given what lambda is equal to. We said that lambda is equal to lambda with a capital 0, which is capital, yeah, just a small 0, sin theta. So this one just trying to differentiate it from the actual lambda. So lambda is equal to the initial, I can say lambda with a small, like a small 0 sin theta. So this is what you replace on lambda, which is, this is the lambda which this is the formula which, that's why here I said note, they have given you this formula. So here just what, replace it. Yeah, so if I replace the lambda here, it will be lambda 0 sin theta, which is, yeah, which is just this one. Then this sin theta, it will multiply everything which is in the brackets. So when I multiply with everything which is in the brackets, I'll have sin theta cos theta UX plus sin square theta UY. Then now I have now to start now solving. Now that's where the integration comes in. I have to do some integration. Since for me to find the force, I have to integrate the differentiation F. For me to find the actual force, I have to integrate this the differentiation. So you know, basically most of the time, you know what's the purpose for integration. For integration is you taking it to the initial state, the way it was. So when you integrate, you take it to the initial state. Yeah, that's I can say that's the main essence of integration. So for you, you have a df, which is a differentiation, the force which is changing. For me to take it to the initial state, which is f, I have to integrate the df. So if I integrate the df, it means that you should always note that the lambda 0, the q0 is C. These are constant. So these, I want to integrate them. I want to integrate what? The cos theta, the sin theta, the cos theta. Yeah. And here the sin squared theta, which is I should do integrate it in terms of what d theta, which is the d theta here. I've just multiplied the d theta with the things which are in the brackets. So if I multiply this d theta with the things which are in the brackets, you have sin theta times cos theta d theta plus sin squared theta d theta uy. So this is what you are going to work with now. This is how you have to solve this one now. So how do you integrate this one now? So this one you have to be really careful when integrating, because a lot of people, they make mistakes when integrating. So we said, if you remember, we said that under coordinate polaire is defined by 0, is defined between what? The angle is defined between what? 0 and 360, meaning the point can move around the circle, making a what? A 360 degrees. And yeah, 360 degrees. So we say that 360 is always equal to 2 pi. That's why here you have seen I've represented it between 0 and 2 pi, and also here between 0 and what? 2 pi. Then how do I integrate if you have sin theta times cos theta? How do you do the integration? So before you do the integration, so for integration, actually, I would advise you to do watch a lot of videos, because that's what you'll be dealing with electricity. Electricity, there's a lot of integration. You just have to know how to integrate. You have to know how to simplify. You have to know how to integrate. Those things are really important. So you have to watch a lot of videos. You have to do a lot of practice for you to be able to have these things on your hands. Yeah. So what you should know is that this one I wrote it in the box. So yeah. So I'll just this is some of the things which you should know. These things are like you have to know what sin theta cos theta is equal to, and this I can say this wherever you go, it will be the same formula. These are the same formulas. I can say this is something which you don't need to calculate. It's something which you just have to know by heart. This formula, sin 2 theta is equal to 2 sin theta cos theta. This one you just have to know it by heart. So that if you know this one by heart, the reason of knowing this by heart is for you to simplify this one, because it's difficult for you to integrate sin theta cos theta when they are together. How are you going to integrate them? That's the problem. So for you to integrate them, you have to find a way of simplifying them. So you should know that there's a formula which is sin 2 theta, which is there's a formula sin 2 theta which is equal to 2 sin theta cos theta. You should know this formula. Sin 2 theta is equal to 2 sin theta cos theta. And since here you only have sin theta cos theta, so you divide by 2, so you have sin theta cos theta is equal to sin 2 theta divided by what? 2. That's what you have seen here, sin theta cos theta d theta. I've just replaced it by sin 2 theta divided by what? 2 plus, you also have to know that there's also cos 2 theta. What is cos 2 theta equal to? So this one also is you have just to know it by heart. It's always the same. If you know this formula, you will know how to simplify your work, because to integrate sin squared theta is really difficult. Like you have a lot of changes to integrate it, and I can say you can take a lot of time just trying to integrate this one. So for you to simplify it, you should know this formula. Cos 2 theta is equal to cos squared theta plus and minus sin squared theta. And you should also know this formula. It's also important. By heart. Then you should also know that cos 2 theta plus sin 2 theta is equal to what? 1. And yeah, so there are two formulas here which you should know. There's one which is cos 2 theta minus sin 2 theta, which is equal to cos 2. You should know that cos 2 theta is equal to cos squared theta minus sin squared theta. And you should also know that cos squared theta plus cos sin theta is equal to what? 1. So these formulas are really important in such a way that if the first thing is you use this the second formula here, since you want to replace sin 2 theta. So we are going to use this formula here. So when you use this formula here, you make cos squared theta as the subject of the formula. So how do you make the subject of the formula? So the sin squared theta just goes the other side. It will become 1 minus sin 2 theta cos squared theta is equal to 1 minus sin squared theta. So this 1 minus sine squared theta, I'll just replace it with my first equation here. I'll just replace it where there's what? Cos here, cos squared theta. So when I replace cos squared theta here, to be 1 minus sine squared theta minus sine squared theta, which I'll have 1 minus 2 sine squared theta, in which the 1 will go the other side, which will have cos 2 theta minus 1 is equal to negative 2 sine squared theta. Then I just divide by negative 2. Yeah, I just divide by negative 2, negative 2. So if I divide by negative 2, negative 2, you see that the 1 will become positive. The cos 2 theta will become what? Negative. So it will be 1 minus cos 2 theta divided by 2 is equal to sine squared theta. So I'm going to replace sine squared theta by 1 minus 2 theta divided by 2. So if I have this now, it has simplified my work of integrating. I won't have any problems in integrating, because I know that when I'm integrating a sign, like if it's just a sign, it's simple to integrate it. When I'm integrating a cos, I know how to integrate. It's simple to integrate it. So I don't know if there's any question here, how you simplify your work, how you replace if you are given, if you find that your things which you want to integrate is complex in terms of sine theta, the cos theta, how you simplify it. I don't know if there's anyone who has any questions here. Hello? Anyone with any questions? Yeah, so basically for this one, you just have to do a lot of questions. And yeah, you just have to do a lot of integration. So this one, you have to know it by heart. And these two formulas here, you have to know them by heart, so that you'll be able to do the simplifying without any difficulties. So now it goes to the integration. So when you come to integration, you know that there's sine 2 theta divided by 2. And here just the same as 1 over 2 times sine 2 theta. So you know that 1 over 2 is a constant. So that's why you have seen here, I've just put it outside, 1 over 2, which is when I do the integration of sine theta. If you remember that circle, if you do when you do the integration, there's going the clockwise way. Imagine going the clockwise way, how the watch goes, like how I can say how you know how those how I can say clockwise. There's how if you have seen how a clock, like how that arrow for a clock moves, it moves in a clockwise direction, in a I can say which term can I use? But it goes, it's like it makes a clockwise. I know you know. I think you know. I bet you know a clockwise turn. You know how a clock moves. A clock moves basically moves from right going to left. Like when it's moving around, it's moving like it's moving from right going to the left side, like it's moving around the circle. But and clockwise, you know that and clockwise is the movement, the opposite movement of how the arrow of a clock moves. It's the movement is moving from as if it's going. It's moving from what? From it's moving from the left going to the right side. Like it's moving in the opposite direction. Yeah. So here when you talk about the integration is the movement in the anti-clockwise. If you remember that circle which I showed you, there's you integrate it. You can when you differentiate sign, it will give you cos. When you differentiate cos, it will give you a negative sign. When you differentiate negative sign, it will give you negative cos. When you differentiate negative cos, it will give you back to what? Sign. That's differentiation. That's when you are doing differentiation. Then when you are doing integration, you are moving anti-clockwise in such a way that you are doing the opposite. When you integrate sign, it will give you negative cos. When you integrate negative cos, it will give you negative sign. When you integrate negative sign, it will give you cos. So it's the opposite of what? Differentiation. So integration is the opposite of differentiation. So when you integrate sign, it's supposed to give you negative, which is the negative cos divided by what? 2. Since when you're integrating most of the time, you when you're integrating most of the time, you when you're integrating something, whatever you do with the denominator, the numerator, you do it with what? The denominator also. So here you see that when you integrate sine 2 theta, you are going to have negative cos 2 theta divided by 2. And when you integrate negative cos 2 theta, when you integrate it, you are going to have negative sine 2 theta divided by, since it was supposed to be divided by 2, but since there's already a 2, so 2 times 2 to be 4. Then here, the 1, when you integrate 1, you know that when you integrate a constant, it's just the same as 0 plus 1, which will give you, 0 plus 1, it will give you, like if you add it's 1 basically. So you have this where the theta is coming from, theta divided by what? 2. So you have to be familiar with integration, you have to watch videos. So here, I'll just multiply the half, which was outside, times the what which is inside here, which will give me a negative cos 2 theta divided by 4, ux, which is this ux, is defined between 2 pi and 0, plus theta divided by 2 minus sine 2 theta divided by 2 ui. So here now, no? Yes? I heard someone speaking. I can't get you. It's skipping. The network is so bad. I can't get it. You are saying? The network is really bad. Can you just try writing in the chat? The chat?
Yes.
Yeah, just try writing in the chat. Like I can't get you. It's breaking. Yeah, so while we're waiting for our friend to write his question, is there anyone else who has any question? Yeah, so while we're waiting for the question, So basically, that's how you integrate it. So yeah, so after you do your integration, you just now after you have done your integration here, even though it's not really what clear. So now just replace where there is theta, you'll be just replacing with it these values now, since yeah, here it was supposed to be 0 to theta, 0 to theta. So that's what we're replacing. So for the first one here to be negative cos, open brackets 2 theta, cos brackets divided by 4 plus cos 0, which is the 0 divided by what? 4 ux. And if you try to solve this one, you'll find that it will give you your answer 0. So this whole thing here, your ux is 0. The whole thing here is 0. That's why I've seen here, I've written like a certain like an equals is equal to what? To 0 plus, then if you try to, this will be 2 pi divided by 2 minus sine 2 pi divided by 4 minus 2 0 divided by 2 minus sine 2 0 divided by what? 4. This one, if you do your multiplication here, if you do your mathematics here, you find that you have your answer, which is pi. So when you try to punch in the calculator, you find that your answer will be what? Pi. So it means this one is 0, 0 plus pi. So 0 plus pi actually is just pi. So it will be, you have open brackets, pi, close brackets. So this pi, you just multiply it now with the rest of this constant, which is here. So that's why you have seen here, you have your f is equal to negative lambda 0 q0 divided by 4 pi epsilon 0 r pi uy. Since here is denoted by what? Uy. For u0, for vector x here, we have found that is 0. So everything here is 0. But here is pi uy. That's why here we have just represented it by what? Uy. And here, don't be confused why you have only written r. You should know that from the start, we had the r squared. So here I just simplified r and r squared, which just gave me r. So don't get confused why we have just written the r. So I don't know if there's any question up to there. Is there anyone with any question? So this is the force which is created on Q0, which is created on the center. So this is how, so basically they don't need you to find the, as in actual answers. Here, electricity, we only find formulas. So you play with the things which have been given to find the formula. So most of the time, most of the things in electricity, you have to find the formula which you use in calculating the force. So this is the force which is created on the center of the Q0. So that's the formula for the force. So it depends if you are given your Q. Sometimes after that, they can tell you to calculate it. So if you know your Q0, you know your lambda 0, you know your R, you can calculate your force, which is created on what? Q0 easily. So I don't know if there's anyone with any question.
Yeah, I have a question. When integrating, our upper limit there was 2 pi, but when plugging in, I could see that it's negative cos 2 pi. Then what happens to the 2, because it's cos 2 theta? So in cos 2 theta, if I in the theta I plug in 2 pi, it's supposed to be negative cos 4 pi.
Which one?
The upper limit we're using there, we're using 2 pi. The upper limit is 2 pi. The number equals 0. Is it supposed to be like that?
Yeah, it's supposed to be like that. And you are saying why here is a plus?
No, when you plug in 2 pi, for in theta there.
Mhm.
What happens to that? Because it was negative cos 2 pi, 2 theta rather. Don't know if you get one.
Yeah, I'm getting it. I'm getting it. Let's wait a bit. Just wait a bit. There's something which I'm trying. Because basically, yeah, you have got the point. Because basically the 2 pi here, which is here, where it has to be simplified, you see, the 4 here. So here, down here, it has to be 2, not 4. Then also here, yeah, here, so here is supposed to be 2, 2, where there is 4, it's supposed to be 2, 2 here. So now I'm just trying to, let me just punch in my calculator. I see what it will give me. Yeah, so that's a nice observation. So basically here, you are supposed, nothing really changes, but you are supposed to simplify, since our friend, like if you see here, there's a 2 and there's a, yeah, if you see, yeah, if you see here, there's a 2 and the other side, there's a what? There's a 2. So yeah, so here you are supposed to simplify it. You're supposed to simplify it. So when you simplify, so we'll get it from here. When you simplify here, it's supposed to be 2, it will be negative cos theta divided by 2. Then here it will be negative sine theta divided by what? By 2. So it's supposed to be 4. So when you simplify it, it will be divided by 2. And when you try putting, like when you try the same one, it will give you the same things. Because I've tried it, the first one has given me 0. Then let me just solve. I'm just patching for the second one. 2 plus. Yeah, so it's supposed to be 2 because after of punching, it's giving me the same answer, 0 and the pi. So here it's supposed to be 2 here. So not, so you have to when you're solving this one, you have to make some correction. So this 2 pi will cancel out with it. No, where am I? Yeah, so here's supposed to be 4. So this 2 pi will cancel out with the 4, and the 2 pi also have to cancel out. Here is supposed to be 4 with the 4, and when it cancels out, you only have negative cos theta divided by 2, and the negative sine theta divided by 2. Then you, after that, just try to do the same things which are here. You find that you find the same answers. I hope it's clear.
Yes,
Is it clear? Hello.
Yes, it's clear.
Yeah. So basically, that's how we are supposed to do it. So these things you just try to watch a lot of videos of integrations. It's very important. Yeah, just get familiar with the integration, all those things. Yeah, but the most important about electricity, the most important thing is, are you following the steps? Because each step which you are making is a point. Each step which you are making is a point. So are you really following the steps? You can make some mistakes there and then, but you should be able to follow the steps. Yeah. So for this is the end for our exercise. This is the end. So yeah, this is the end for the exercise 3. I'll send this PDF, and please don't forget to where there are mistakes. Yeah, don't forget to rectify the mistakes. Where there are mistakes, don't forget to rectify the mistake to correct the mistakes. Yeah, and I think for today we're just going to end here with one question, so that next time, since there are just some few minutes which are remaining, next time we should we'll start with a new chapter. Yeah, next time we'll start with a new chapter. Have a blessed day, everyone, and enjoy the rest of your lessons.